The gravity of the time is such that every new avenue of peace, no matter how dimly discernible, should be explored. Never before in history has so much hope for so many people been gathered together in a single organization. You will provide a great share of the wisdom, of the courage, and the faith which can bring to this world lasting peace for all nations and happiness and well-being for all men.
Well, welcome everybody again to another episode of Titans of Nuclear. I'm Ryan Howell. I'll be hosting today, and we have with us Nolan Hertel, a professor from Georgia Tech. So thanks for joining us, Nolan.
You're welcome.
Just to kick us off, why don't you tell us a little bit about your past, where you grew up, and got you into nuclear?
Okay, I grew up in a relatively small town in Texas called Kerrville, Texas, kind of in the Texas Hill Country. Then I guess in high school I was interested in physics, did well in math, and so I went to Texas A&M, got a bachelor's and master's degree there and pretty much in traditional nuclear engineering, and then went to University of Illinois in Urbana-Champaign, got my Ph.D. there, worked with guys who mainly did neutrons, and was kind of a great experience there. And I'd say my current interests that went strongly towards neutron dosimetry, radiation protection, was kind of spend some time at Pacific Northwest National Lab in the late 80s. And that kind of set me on a direction to do computational dose stuff. So I have background there and in shielding. I don't do reactor physics. I understand what they're talking about, but that was my choice not to do those things. So.
All right. So what kind of stuff were you doing at PNNL then?
At PNNL, I worked with the dosimetry group, and we were looking at that time, the International Commission on Radiation Units and Measurements had come out with new quantities to use for instruments. And so we were kind of delving through those and modeling sources they calibrated with to see what they should be reading to simulate those responses. So
very cool.
That was a lot of Monte Carlo work in that setup.
That transitioned you kind of into the modeling side then? So
yeah, that's what I got into, doing a lot of modeling side. And that's carried through is if you use American National Standard 6.1.1 to convert from neutron intensity to dose, you're using numbers that I helped calculate, as well as was on the group that formed that standard. Also, just recently, about 2 years ago, ICRU released its new operational quantity recommendations. I co-chaired that, and so a lot of my numbers are in there. And so kind of, if I really wanted to brag, I'd say probably if you convert from neutron or gamma ray field strength to dose, you probably use numbers that I either help generate or help select. So it's
very neat.
But that's a rather small
contribution. Yes. So yeah, no, that sounds like a lot of fun. Any other passion projects throughout your career?
Well, it's interesting, and I like to tell young people this. Sometimes things that you think are negative in your life turn out to be something you can actually use. And in a technical sense, I was made the director of the Georgia Tech Research Reactor on the same day that the president told me that at Georgia Tech. He told me, I sent a letter to the Nuclear Regulatory Commission saying we're going to decommission it. So jokingly, I say I've never been there when the reactor on light was lit. And so as a result of that, God, if you follow decommissioning, I like to jokingly say there's only maybe 100 people who do actual decommissioning. And they're always working for a different company the next time you bump into them. But as a result of what we did there, I've done a fair amount of consulting over the last 20 years looking at calculating radioactivity levels in the parts as they tear it apart. In fact, I'm involved in, 3 such things right now. And, the idea is we know that we haven't calculated the absolute truth, but we're giving them an engineering estimate of what should be, say, in the stainless steel. And then they can say, here's how we're going to box that up to minimize waste, cost, and what we may have to be careful of when we go start cutting and chopping things up. So that kind of a default has become a passion. But my biggest passion really was measuring neutrons over the entire 40-something years of my career. So.
Yeah, that's fantastic. Is that something you're continuing on? I know you're partnering with Oak Ridge National Lab.
Yeah,
Can you tell us a little bit about that work?
I came back there, in 2013, I became what we call a joint faculty appointment. Oak Ridge National Lab has 7 university partners, and each of those have a kind of streamlined approach to have faculty members appointed jointly, which can mean they can pay you 0 and don't expect anything from you, or they can get up to a significant amount of your time. And so I did computational dosimetry there until about 2 years ago. And then we've been doing some neutron measurements to basically better calibrate their dosimeters. So what we'll do is we'll make a measurement with a system that'll give us a crude neutron spectrum, convert it to dose, and then they'll put their dosimeters on a slab phantom to replicate the backscatter from the body, and then we'll see how those are. And usually if you have a really good measurement of the actual neutron dose, the dosimeters over respond, and so you can reduce your dose of record. And that was a big thing. We did that at a couple of power plants too, which gave students an opportunity once to go in containment at a PWR during power. They should have let me go in because the oldest person should take dose, right? However, they were so excited and they would only let 4 of us in. So I got to sit in the waiting room while they had all the fun. But those are things that people have done to better calibrate their dosimeters for use in the actual fields that they work in. We have laboratory sources, but those may have different energy dependence, which could lead to an overestimate of the dose that we read on these dosimeters.
So what facilities are you using then up at Oak Ridge? What do you work with mostly?
Well, we've gone to several facilities like the Radiochemical Engineering Development Center, where people handle things that may give you neutrons from alpha reactions with oxygen. So it's like if you have a solution with curium in it or something. So we've done a few measurements there where they put together californium, extracted californium. We've done some stuff there. Somebody had a DT neutron generator, so we went to that facility, made some measures. We also made some measures, spliced a neutron source where suddenly you look and say, oh, there's a little seam in the concrete. Oh, well, neutrons are actually coming through. There are many seams in the concrete, but there's actually some low dose coming through. So principally, we've done that and then calibrate the system at their calibration facilities with some known sources. So I have a few more. How's that? May 31st is my last day of work at Georgia Tech. June 1st is my first day of retirement. I have to say it correctly for them. And starting after 30 days, I can work part-time again for Georgia Tech. So there are still a few places to make neutron measurements that they wanted to look at. So probably in July, I'll dust off the equipment if I can find it and go back up there for a couple of weeks.
That's fantastic. Congratulations on the retirement. And it's great to hear that you're still going to be playing in retirement.
Yeah. Well, I say I am not a strategic planner. And so when people say, what are you going to do? I say, well, I'm going to move back to Texas eventually. That may be 4 months. It might be a year. But, my wife has plans to move back sooner. So it'll probably be more like 4 months.
Yes. Well, very good. Any plans to get hooked back up with Texas A&M when you're out there?
I don't know. I think I have several opportunities here still doing shielding with people, and most of that can be done, now virtually.
Right.
They send me the plans and stuff. I can do that. Although it is good sometimes to look face to face at people. But I probably I'm not really crazy about teaching more courses. Okay, if there are short courses someplace, I'm happy to do that. But I'm probably not going to go back into a classroom setting. I don't think at this time.
Sure, sure. So tell us a little bit, something people might not know about the role nuclear energy and specifically some of your work in shielding and neutron calculations. How is that going to play a role in the energy transition?
Well, I think with some of the small modular reactors, things are changing some. When you look at like the molten salt concept, and I asked this question once to a group of students and got no answer. But I mean, things like delayed neutrons, right? So now you're pumping the salt around, whereas before, say you have uranium oxide fuel. Well, all that's trapped in the fuel, right? So delayed neutrons are in the core. Well, now if you're pumping that around, I said, have you worried about, are you going to see neutrons in other areas of the plant that you normally only saw gamma rays? So I think they're interesting things. And then I saw one design where it looked like people may actually go on the deck of the reactor while it's operating, which probably means a bigger neutron dose. I mean, currently at PWRs, you might go into containment. At a VWR, you never do while it's operating. PWR, but you don't ever take a direct look down at the pressure vessel. So there are neutron fields there. So I think that remains to be seen. Some of the things like portable reactors, are mobile. We probably call them mobile, right? They can be moved. Like some of these three, and I don't know all the terms. They call them micro reactors, right? 3, 5 megawatt electric. Say if you're going to move that, are you're going to have to now think about, did I contaminate the soil? Did I activate the soil? If it was on a concrete pad, can I just load it up and move, or do I need to take some care in what's left behind? So do that. So I think those are big things. The other thing that kind of recently, I've been doing shielding on electron beam machines. When you make Bremsstrahlung. So one of the companies here is a non-destructive testing company, and people are using 6, 10 megavolt machines, which I think used to, it's quite different than using 250, 450 kilovolt X-rays. So I'm more worried about putting them in shielded rooms. I've been doing some of that, and then also with a local company who does food irradiation. And so they have some unique problems. They actually have a food irradiator now operating in Mission, Texas, and approved. And so there are things like that are a little bit. Some of the things are new to me, not new to the world of physics, but I mean the actual shielding of those facilities because they look a lot different, say, than typical accelerator setup, where you have a gigantic shielded room and the beam comes in, and so that's a kind of growth area maybe for me if I keep doing something.
Yeah, sure. Let's dive into that a little bit, because I know you're a past president of the Council on Ionizing Radiation Measurements and Standards. And that certainly for me, getting involved with that group was kind of a broadening of my viewpoint and just how much the nuclear industry touches, everything that we're doing as humans, across healthcare, industrial sterilization, like you just mentioned, and everything we're doing with nuclear power.
Right. I think that's a thing that we probably in nuclear engineering education don't pound on our undergraduates enough. That, hey, accelerators are widely used for a variety of things. I like to point out to them, and I think this is still true. I can mention a brand name, can I? They used to say that the ink was cured on the late Ego packages by electron beam. Wow. then if you look in Georgia, in the paper industry, you use actually, I think they use radioactive gas. I don't know whether it's xenon. I don't remember quite, but I mean to gauge the thickness of the paper as it rolls along, and so there are all kinds of uses. Now there aren't hundreds of jobs for bachelor's level nuclear engineers, but they need somebody who understands, radiation interaction. So I always try to tell them, you have the fundamental tools to do more things than reactors. You just haven't thought about them. And so we used to teach a course here called Nuclear Sources and Applications, where we tried to say, here, a brief look at accelerators. Here's what people use neutrons for other than to make fission in reactors. Here's what people use photon beams for, a lot of things like that, So I think, but KERMS really opens it up. If you see that, you're amazed at all the industrial uses, because you're going like, oh, these guys are hiding away someplace where the rest of the nuclear engineering community rarely sees them, right? But they work very strongly on a lot of industrial processes. One of the things the local company told me here is that they've been making X-ray cabinets suddenly in big demand in California for sterilizing cannabis.
Mm-hmm.
Would you have imagined that? I mean,
extending shelf life of all things.
There you go. So, I mean, it's kind of interesting as you meet people who don't fit quite into the power plant picture, the things that are being done that, say, the average nuclear engineer never thinks about, I think.
Yeah, very innovative and novel ways of using radiation. So in your opinion, what's been the most significant discovery or breakthrough in nuclear technology over the course of your career? What is that, and how do you think that's impacted the industry?
Well, I think, that's a hard one.
Lots of neat things have been going on.
There's nothing new under the sun, though. But I guess in applications, I think particularly, and I've had some interactions with people, medical physicists. I think if you look at how things have progressed from an old medical physics radiotherapy treatment to what they do now is incredibly fancy, using micro beams, shooting different directions, and then moving to proton machines,
proton therapy, for sure.
and ultimately to carbon ions and things like that. And so that I think that's kind of interesting. In fact, that's how kind of got my start with my master's degree. I worked with a guy at Texas A&M who was treating for MD Anderson cancer patients in the Texas A&M cyclotron with high energy neutrons. Mm-hmm. That kind of died over the years. But now with these higher LET radiations like protons and carbon-14 have some of their impacts. And I think a lot of this stuff like monoclonal antibodies, where we've tagged things that go to specific locations with alpha emitters, all of this is pretty exciting. In nuclear engineering, I'm trying to think like power reactors. Well, we've eliminated the number of pumps, but that sounds kind of mundane. I think in general the generic things we do is pretty much stayed the same. And it's kind of like all of a sudden people are interested in molten salt reactors, but a lot of the first reactors were molten salt, the experimental setup. So it's kind of like you go back to that. The other thing I find interesting sometimes is, there's this old journal called Nucleonics, written in the 50s. And if you go back in there and you look and you say, this guy had a great idea, but they just didn't have micro and nanoscale electronics. They didn't have all the technology we did to interface with that. And you say hey, that idea would now work. And you see occasionally somebody will pull one of those out and you'll say and I'm thinking more about detection, radiation detection, that there are a lot of concepts back then. So the biggest thing, I don't know. One of the biggest thing is maybe more political. Suddenly, people like us.
Yeah.
I lived through all those decades, of Chernobyl. I started at the University of Texas, and I was there like a year or so, and then there was Chernobyl, and so we actually did a lot of public relations stuff where we would go to even elementary schools and talk about how reactors work and things like that. And then we kind of went through a cycle where, everybody was against nuclear power. Now they see it as one of the major solutions to climate change. So that's kind of, I don't know, that's not a technical change, but that's an amazing change in attitude among the average citizen.
Yeah, no, that's definitely been a great shift for everybody. I certainly feel that nuclear is going to be helping us get to net zero and beyond. So that's fantastic. Um, has that impacted your work at all? Did you ever see any, public perception or pushback with, trying to find funding throughout your career or anything like that?
Well, yeah, there were lean years, I think, and that's why I did when I was at the University of Texas. I was there for 14 years before I came to Georgia Tech. And I probably should have left 10 years earlier than I did, but I won't go into that discussion. It was a rather small group of faculty. But I worked on the Texas Low-Level Radioactive Waste Disposal Authority. So I got some insight into waste disposal, not high-level waste, but low-level waste. And I think in the kind of lean years, people were, I kept that kind of going, and then did some things after 9/11. Suddenly we became interested in can we scan people who might be contaminated and decide this person is going to get a big dose, so let's do something. This person can go home, take a shower, and probably be okay, even though they have some internal contamination. So we got a fair amount of work done for about 10 years with the CDC on how do you have people walk through portal monitors and stand at them for a minute and determine whether they're contaminated or not, and back calculate some numbers. So I think that was kind of the lean years, and then what you do is you find yourself old suddenly, right? You don't know this is happening when you're a university professor, because I hung around with kids who are only in their 20s for 44 years, right? And then
time flies when you're having fun.
and then you go like, oh well, at the later stages of your career, they're going like, well, we need to give young people funding. So there's this always challenge, particularly in the area I'm in. It's not like overwhelming. Had I been maybe a mainstream reactor physicist, the last 10 years would have probably looked pretty good, a lot better. I mean, it doesn't look bad. I did a lot of good things that I enjoyed, and got paid to do them. So it was fine in that sense.
Yeah. So what's you talk a lot about looking at decommissioning, and you worked a little bit in the low level waste disposal. What do you think the outlook is for decommissioning, especially if we're entering into this next phase and putting a lot of new small reactors online? What do you think is going to happen there?
Well, I assume most of the existing power plants, and I guess what we've seen is if there's more than one unit at a power station, it's economically viable. I think we've lost some, like Kewanee nuclear power plant, right? Because it's one unit, and I think you can economically operate if you have more than one unit, because you can double use the crews, I guess. So I don't know, but I guess Palisades nuclear power plant, Holtec seems to be saying, hey, let's get that loan from DOE and restart. The governor of Michigan seems to stand behind it. So I think the big ones will still be there unless they're just totally outdated. I think probably what can happen with small modular reactors is, say 30 years ago, we built a reactor or more. We didn't really do a chemical analysis of the steel, like how much cobalt-59 is in the steel, which actually drives a lot of the dose rate you're going to get when it's over. And I think now we have the opportunity as we build these things to say, let's characterize really well what we put in, and then the modeling that people can do will be much more accurate. So we kind of have a better idea, although I guess the old pros who've done a lot of this for the companies have some idea in their mind, what the rate is going to be. But I think that's an opportunity there. And a lot of these things the refueling on some of them lasts a lot longer than typical. And so I think, everything's different in that dynamic. But I guess I don't see that the nuclear waste ultimately going away. I do think we'll see a kind of a different maybe time sequence of when we get rid of things and how we get rid of them. And, we're still waiting for that fusion reactor to come online, I always get upset when people say, well, we don't make radioactive waste. Yeah, you do. It's just a different kind.
Yes.
So it's I'll tell you an anecdote here. There's a guy I know who got his Ph.D. in 1956 at the University of Texas at Austin. And I shouldn't say this will make fusion guys mad. And he actually did aircraft, nuclear powered aircraft shielding. And He told me in about 1988, he said, when I graduated from University of Texas in 1956, there was only one constant in fusion, and that is that in 50 years we'll have a fusion reactor that generates electricity. He said, and that stayed constant the whole time through my career. And I'm going like, okay, but I think we're close. We're closer, I guess we should say.
Gonna remain hopeful on that front. Yeah. So
yeah.
hopefully these SMRs can take us through.
Gives us something to shoot for, right? That the energy of the sun, right? So we're good.
Yeah, no, I'm at least excited. SMRs getting us through. I've heard the new fast reactors can actually take spent nuclear fuel and burn a little bit more out of it, so we could potentially fuel the new generation of reactors with some of the older fuels, and hopefully that'll be an extra stopgap to get us to the next level of fusion.
Right. No, I think we'll ultimately get there. The question is, will it look like anything like we're thinking right at this moment? Maybe, maybe not. So we'll see.
Yeah. Well, what you said you work with a lot of students, so I'm sure you get this question a lot. But what advice can you give to someone starting out in the nuclear industry, based on your experience and perspectives? What would you tell someone?
I think sometimes, the current generation may not stay at a job as long as I did, okay, and people in my generation, okay, and they may move around a lot, but at the same time, I like to tell them, you got this starting place. They're not, they say, I'm not sure whether I should take this. I say, look, you go there, you work 2 or 3 years. If you don't like it, you got like 40 years left to work, and you'll learn something that'll help you. So I think one thing is to recognize the first train ticket may not be where you wind up, and to learn what you can there. And I, there's another local company that did dry storage containers, and people would say, well, should I work there? I said, well, yeah, if you go there, you're going to do criticality, you're going to do shielding, you're going to do stuff like center of gravity calculations for the containers. I said, there's no other place where you can do all these things. And then, if then you can move on, somebody wants you, but I think the real thing is to look at, if I don't like it, I'm still young. And I get the same thing for people who go like, well, I'm thinking about joining the Navy, nuclear Navy. And so what, that's a 6-year commitment. I say, okay, so you're 28. You got a lot of things going for you, and you got some things going for you that the guys who graduated with you don't. You've been commanding people. You've been managing people, and that's an asset. So I think, not to lock in like what I do next, not to get too anxious about what I do next. Is going to be what I do forever. And particularly, I think if you go into graduate school, you're going to say, is my thesis going to be the only thing I ever do? Well, hopefully not. Hopefully you get way beyond that. So I think that's a piece of advice. So they don't get so anxious about choosing between 3 or 4 options.
Sure. No, that's fantastic. And, certainly that's been my feeling, been in the nuclear industry. I think the last time you and I ran into each other was at a conference in South Africa. So I always tell people, nuclear can take you all around the world. Yeah. Yeah.
Well, and this goes back to my upbringing. I never dreamed I would, I went to Mexico when I was in high school once, and probably I've been in innumerable countries. I've even been to 2 of the secret cities in Russia, because I was on the Department of Energy Russian Health Studies program. Now, we were highly monitored. They wouldn't let us spend the night in town, but we stayed in Tomsk and in some sort of resort outside Ozarks. But I met a lot of people, and I think that's one thing. You go around the world, you meet people, and they're interesting, and we all get along on the personal level, regardless of how our governments are standing off and doing things to each other. So I think it's opportunities. Yeah, I guess the other thing to tell them is nuclear power is a global industry. And so, I used to work with a guy at the University of Texas at that time. Besides the U.S., France was where all the real France and Japan were where the big actions were in nuclear power. And he'd tell them, you should learn French. But I mean, I think there's a certain amount of truth that I should be, looking around the world to see how we fit in, and that's a unique thing I think about this compared to some of the other industries.
Sure, definitely. Well, yeah, you've had quite a long career. You've been a lot of places. Can you tell us a few of your favorite stories, or some of the crazier things that you've been a part of that have been fun and interesting?
Well, I tell, and this again from a small town boy background. I tell my wife, if I write my memoirs, I'm going to entitle it "I Fell Down on 3 Different Continents," because I fell down in China, I fell down in France, in Poland, of course in the U.S., and you go not that I fall down a lot. It's just I can look back, on those. So those are kind of interesting. I don't know about weird things, but but I guess some of the interesting experiences when we went to Ozars, it's like the 007 movies where you see the 2 fences and dogs between the fences, and we drive up there and they come on board, take all our passports and look at them, and they're armed, but it wasn't what it was say 20 years before, because the dogs are kind of sleeping under the trees and stuff like that, and so it was kind of a total different thing to be watched, and I don't know, just going places, and I think for me, one of the big things is the Europeans are much more interested in measuring dose as closely as they can because they've set their dose limits much lower. And so I feel like it's weird that I probably have more contacts in Europe that know what I do than people in the US, rather a small group. So, but as a president of the Health Physics Society, in 2018, I went to China for 11 days. I was able to bring my wife, and they paid for her once I got her ticket. And we went there, did some sightseeing, and that was really interesting. But I fell down there, and this is a funny story. This is kind of funny. We had a hostess who was taking us around, and so there was some sort of wedding band playing outside because there'd just been a wedding at the hotel. And so I was going to go out, and I said, you two wait here. I'll go out and take a picture of the band and play it. So I went out there, and when I went out there, there was a lot of dust on a marble slab, and I fell down and hit knee first. And I thought, I'm sunk now. And so it took me a long time to come back in. And the woman who was with my wife was just really worried that something happened really bad, like I was abducted or something. I don't know what it was, but that was a challenge. So it's, I should be able to come up with better stories than that. But anyway, that's kind of it.
No, that's been great. So, getting around the world, getting to meet people, like you said, you meet a lot of interesting people, but I love that, like you said, everybody is kind of, geopolitics aside, we're all kind of interested in the science and can really, communicate on that level and connect on that level. That's fantastic.
Well, and one other thing that comes to mind, I've been to Hiroshima maybe 5 or 6 times. And, my father actually turned out that he went into Hiroshima 30 days after they dropped the bomb. I mean, he was just a chief petty officer. So, it wasn't anything new, but he never told me that. So I read his diary after he left, and he said he went into town and he bought stamps at the post office. And I'm going well, surely they sold, U.S. personnel stamps. And then I realized when I walked around the town where they show you where the post office was, that the post office shut down for one day and reopened the next day after the bomb was dropped. Windows were blown out. And so I you're standing there and say, hey, 75 years ago, my father stood at this very location, but he never told me. And then I understand he bought the stamps as a souvenir. And so it's kind of interesting going around the world, things happen. You bump into people you never thought you would meet, and sometimes they have a strong connection to a similar background. So that's been an exciting part, I think, of my career.
What else do you think we can do to further the nuclear industry? Yeah. What steps can we take to spread the word? I know there's a lot of excitement right now and a lot of energy need, especially in Europe. But what things can we do to spread the word?
I think, and we've always said this, but I think if we can just speed up the process of building plants, and maybe that happens with things maybe being manufactured in a factory with SMRs, but I mean, just like Plant Vogtle, well, 3 is now online. I think 4 is getting ready to go online, but you know what? A bunch of years after it was a long time period that was
lots of money
scheduled, and it's even longer now. And in a sense, the Southeast is in great shape, I think, because of its dependence on nuclear energy. But I think if somehow we could, lower costs, obviously. But I mean, if we can go to a much shorter time period where people don't say, "Oh yeah, we're getting hit big time by the Public Utility Commission to pay for the interest on this plant," So I think there's a financial side that comes with this that we have to, and I guess with standardized manufactured designs, that should help in that regard. I think too, we probably need to preach a little bit more about actual radioactive releases from nuclear power plants of all type. Like, I think, years ago, there was an old study that, coal-fired power plants spit more radioactive material up the stack than a nuclear power plant did. So that's, I think that's something that people don't know. And high level waste, right? We see that diagram. Here's a football field. We take all the high level waste and encapsulate it, how small an area it takes up. I think that, and to let them know that we have good engineered systems to take care of it. So those, I think, are biggies. From my perspective. I don't know. There was one other, but hey, I'm old enough, it slipped my mind, so it doesn't matter.
No, that's good. That's very good. Yeah. So definitely want to spread the word and get people excited about it, and certainly speed of implementation, I think, would help for sure. Oh, we're coming close to our time. I don't know if you want to add anything else. We certainly like to end with kind of casting a vision for nuclear energy to the future. So what do you think energy around the world will look like in the short term and far term?
Well, it seems to me like small modular reactors, and especially things that are maybe sub 200 megawatt electric, that they're now remote locations. And I think, Alan Walter in one of his books did an analysis on healthcare versus salary, and it's all tied to energy production. Mm-hmm. So a lot of the remote places in the world where we don't want to run gigantic transmission lines, right? And we already have a transmission line problem in certain parts of our country. It makes sense to have small reactors that we go out there, and then maybe they don't have to be tended to for 15, 20 years. And I see that developing. And I know that particularly in Canada, they think about indigenous people up closer to the Arctic Circle. Well, let's go drop a 20 megawatt, 30 megawatt electric, basically closed system there, and then we only have to run local lines and stuff like that. So I was surprised a couple of years ago when I was on a review team for endowed professorship in Canada, that they were really thinking strongly in that direction, that SMRs were really good for those remote regions where you don't want to run transmission lines. And so I think the whole system can change somewhat. And then I guess the other thing we see in the U.S. that's kind of interesting is we can shut down the coal-fired power plant and we can relocate multiple modules. Sure. And use already existing cooling water. I assume transmission lines, I may need some upgrading, but I think that's a distributed source. Years ago, one guy kind of got on me about this. It's like about 35 years ago. He said, well, you know, the problem with nuclear power is it's all centralized, should be distributed. And so we now live in an era where, hey, it can be distributed. I also, tongue in cheek, say, you want electric charging stations along the tens of thousands of miles of interstate highway? There you go. Drop a micro reactor every 200 miles or something like that. I mean, there are all kinds of concepts, I think, that are now open that we can distribute and get things in locations that before was a major task with getting the electricity there afterwards. So.
Yeah, very, very interesting. So actually dropping power plants in remote locations to bring power and empower those local communities. I love that.
Yeah, I think, and there are places you can think of that, we now no longer need massive transmission line setups. I mean, we probably don't want thousands of reactors in the country, but I mean, there are locations you can easily think of that, would work pretty well if we could drop a small system in there.
Fantastic. Well, anything else you want to add?
No, thanks for this. And
yeah.
Sorry it took so long for me to connect.
No, it's been certainly great to have you, Nolan. Great to catch up with you. Great to hear everything that you've done. Thank you for the many years of service in the nuclear industry, and we certainly look forward to seeing you around in your retirement.
Okay, well, it's been fun. When you go to a retirement party for faculty members, and we had one, they don't say you're retiring. They say, well, what are you going to do for the next stage in your career?
Right.
I hadn't thought of it like that, but I don't know. I hope I don't immediately ride off into the sunset, but I mean, it'll be a slow ride.
Yes. If I know anything about nuclear, once you're in, you're in. And it certainly sounds like it's been a passion of yours. So I'm sure we'll see you around.
All right. Thanks, Ryan.
Thank you very much for your time, Nolan.
And initiate at least a new approach to the many difficult problems that must be solved in both private and public conversation if the world is to shake off the inertia imposed by fear and is to make positive progress toward peace.